Okay, everybody, it's the top of the hour, and I think we'll get going here. I'm Al Morton. I'm one of the co-chairs of the Benchmarking Methodology Working Group. Sarah Banks will be will be joining us in about 15 minutes. She's got another engagement early this morning in Pacific time that she I think couldn't avoid. So let's begin. Everybody got here on time, including all the folks whose clocks changed on Sunday, so that's good. And I see we've got about 18 people here right now, which is another good thing. So let's proceed. If you're not currently subscribed to the BMWG mailing list and would like to be, please go to the link on the first slide there, and you can subscribe. All right. So it's very early in the week, and that means we need to go through the note well fairly carefully so that folks understand that as we go into the meeting. And also we, folks will see this all as we work along, but one of the things I like to note is that we all work as individuals, and we try to be nice to each other here in Benchmarking Methodology Working Group. And that's not unique in the IETF. But there are some places where there are, some very spirited discussions, shall we say, and we need to follow our code of conduct, and it boils down to this. So I hope that we'll just continue on as we have been in our friendly and working group where folks recognize that the technical arguments are what we're trying to make here, and the best technical argument wins the day. All right, so you, by participating in the IETF, you agree to abide by its policies and processes, and any contribution you make is covered by the patent policy of the IETF, and we ask that you acknowledge the patents that might be part of the work, or any contribution you make. Contributions are basically anything other than sitting on your hands and saying nothing. It's comments you make in the meetings, email you send to the lists, comments on the chat. If you help out with the minutes, that would be a contribution as well. And it's all covered by our policies. And if you have any questions about these, you can talk to me or our AD advisor, who is Warren Kamari. Warren's here, and also if you love to read about all of these things in the IETF best current practices, there's a whole list of them here that you can check out. So I think I've seen us through that pretty well. And now we can move on to the next point, which is our agenda. And we get to bash the agenda if necessary, but here's what we've got. The working group status, we'll mostly talk about the EVPN draft. Then we've got a couple of working group drafts to talk about. We've got a working group adoption call, which went, I'll say, differently than other adoption calls that we've had, and we definitely need to talk about that, which is why I didn't compose a message to the list. Further, proposals, we've got the benchmarking methodology for stateful NAT XY gateways using the hash and stuffing pseudorandom port numbers. That was one of my favorite drafts and RFCs in this group. And a brand new, what I would call a considerations draft. It's in our history, it's titled The Problems and Requirements of Evaluation Methodology for Integrated Space and Terrestrial Networks. That's biting off a lot, but we're going to hear about it today in the time available. So, any bashes to the agenda? All right, I see no requests for the floor. Can somebody help me out with the note taking today? And of course, the way you do that is with the note taking tool. And the note taking tool has already been populated with the agenda and the various topics we're going to talk about. So it would actually be very easy to do. It's just something that you have to capture our agreements at the end of discussion. If there's a big question and a big answer that follows, then it would be nice to capture that as well. But otherwise, we'll do the best we can here. And as I said, Sarah's going to join us a little bit late. Can I get a volunteer to help out with the minutes? All right. Well, I hope I'm going to ask that question again shortly, and hope that we can move along here a bit. So basically, our brief benchmarking working group status is the Ethernet VPN draft that went up to IESG review quite some time ago, received 5 discuss ballots, which are blocking ballots, and they need to be resolved by the authors. One of the authors basically said that they were working on resolving the comments, but then he was looking for his co-author to agree, and then not much happened. So Warren imposed a deadline of October 31st where we would declare the document dead if there was no progress. And unfortunately, October 31st came and went, and we have seen no progress on this. So Warren, I'm going to ask you to sort of step forward here, and it looks like you're joining the queue, I think. Where's that? Where's the queue? Warren, did you join the queue?
Yep, the queue is under the participant list, which is to the right.
Oh, yes, good, thank you.
No worries. Got it. So yeah, I mean, I don't really want the document to die, but we've been waiting on the authors for a really, really long time, and I can't seem to get a hold of them. I've sent them a bunch of mails, both through the data tracker and directly and similar. So I'm not sure if the working group wants to add some additional authors who might be willing to help deal with the discussed positions, or what. I mean, I'm okay leaving it in its current state a bit longer, but I would really, really, really like to see it moving along, just because it shows up as a big red thing, and data tracker keeps sending me grumpy emails.
Yeah, I think that's, I mean, to cover all the bases, I like your suggestion of asking if there's anyone else in the working group who would like to pick this work up and deal with the discuss ballots. I know that one of the authors has lost his place, and I saw another announcement too that led me to believe that maybe the second author had the same problem. So we'll have to see whether anyone is willing to take this up. And yeah, I propose when Sarah rejoins us or joins us, maybe at the end of the meeting, let's revisit this and discuss it then. Oh, Sarah's here. Good. Hi, Sarah. I think she's still, maybe she's still in the process of joining.
So I guess she might also just be looking for her microphone thing. So I guess we'll give her the summary of where we've gotten to. So specifically on the EVPN draft, I mean, I'd sort of said by October 31st, if nothing happens, I was going to mark it dead. And we haven't managed to reach the authors, but I really, really, really don't want to mark it dead. So at the moment, I think we're trying to see if there's anybody else who wants to volunteer to step forward and sort of help carry the document over the finish line. I've sent probably 5 or 6 attempts through the data tracker to reach the authors, and then once on the list with a somewhat passive aggressive, you all need to do stuff or I'll mark it dead, and also about 7 or 8 off list emails with no luck. So apart from actually just getting all of the comments addressed, there's also going to be the problem of at auth 48 time, we need all of the authors to acknowledge that they're okay with the changes. So we do still need to reach them in some manner. But I'm not sure if you can speak yet. Okay, so hopefully Sarah has more luck managing to reach the authors than I did. I got some bounces and the rest of them just sort of seemed to disappear into a black hole. So
yeah,
give it another try.
Yeah.
Okay.
And interestingly, let's see here. Oh, okay. Oh, yeah. I was trying to take some notes, and now I figured out how to do it. So, the real question is whether anyone else in the group will help with this, and that's the discuss and auth 48. Okay. All right. All attempts to reach authors have failed. Okay. All right. So I can sort of remember that Sarah's always had some difficulty getting the real-time media going. So let's see how that works out. Good, but thank you for that suggestion, Warren. I think we'll try that and as a last-ditch effort, and then let you know what happened. Maybe a couple of weeks request. See if this is important enough for anybody else to pick up. Okay, so on the next generation firewall, actually this is just our status part of this. We had our last working group last call on this. The comments were resolved. Went on to the document shepherd, and we need some things added to the latest version of the draft based on the shepherd's review, which is me. So that's the status there. We got a lot of new comments on multiple loss ratio search, which is the other new working group document. And of course, the proposals keep coming. So that's where we stand in general in the working group. We've got no new RFCs. We've had a nice stable charter for about 4 years, and we like it that way. So unless anybody's got problems with the current charter, we'll just leave it as is. And we have a supplementary BMWG webpage that I haven't visited in a while, but I hope it's still reachable. So Brian Monkman, I see you're in the queue, sir. Please go ahead.
Yes. Can you hear me okay?
Yes, I can, Brian. Go ahead.
Okay, good. Quick question. First off, our apologies. We totally missed the attachment when you sent it out. I mean, all of us did. So I'm not too sure what happened there. we reviewed it, and everything makes total sense. The one question I do have is, should we create a new version before it gets passed over to the area director for review, or should we wait until we get the area director comments back? What should we do?
I suggest that let's send Warren our cleanest version possible. And then, I mean, they're basically all editorial things. The only one that I thought would involve some work was checking one of the references to see if an updated version could be used. And that came out of the NITS check.
Right. But yeah, that's pretty straightforward. But okay, fair enough. I'll once I think we have something. I mean, if we're going to change the references to something newer, then we should probably just do everything, and then so it's done, and we could pass it on with all of your comments addressed.
Good. And then I'll push the button. There's a button to request publication request, and that's when Warren gets it for his review, and we'll take it from there.
Okay. All right. I'll send you an ETA once I have that finalized.
That's great. Thank you.
Okay. Great.
All right. So that covers the next generation firewall part of our agenda, and I've mentioned this a couple of times. It's important to include that obsoletes 3511 in the abstract. It's just the way people do things. So let's do that. All right, and let's see here. So the authors will do that, and NITS. Okay. All right. So then we've got another status here, which is basically the multiple loss ratio search. And yeah, what I want to do there is I'll basically share my screen, which is going to be a little different than this. Let me go away from the slide share. And then I'll do the screen share. Yes, I do. And I want to. So I'm guessing this is really small. My notepad here. Is that the general impression, folks in the audience? Should I try to make this bigger? And that's, of course, not going to do it alone, but what's my font size thing? Well, it might actually be, yeah, it's actually more visible here. So and this is the notepad that I mentioned before in the editing mode. So on the multiple loss ratio search, Masiek posted a status late last week, and what we've also got is some comments that have been made by Gabor, and Veratko has been commenting or sort of responding to those comments. So we've gotten some reviews, and then Vladimir posted comments over the weekend. So that's great. I know they haven't had a chance to respond to those, Vlad, but it appears that there's plenty of material for the authors to take back and consider and work on an update of this particular document. And we've had lots of discussion of this thing on its way to working group adoption. So I think that's this is a document that's on its way. So we're just looking forward to update 02 to reflect comments. Okay. All right. So any further comments on either of these drafts? We've gone through these pretty heavily. We're developing a multiple loss ratio search toward a working group last call. We've had many last calls on the security device performance, and I think we can be happy with what we've accomplished with both of these so far. We'll see a little more. We'll see a little more work on both of them before we send them on. All right. So we're making good time here. During the interim period between our session at IETF 111 and IETF 112, we had a working group adoption review for the Yang model, a Yang data model for network interconnect tester management. And you can see the document is here. It's been updated October 25th. Thanks to the author for his update. And this is what I meant when I said that the working group adoption was a little bit unusual with this. We got there were some comments in September, early September when I started the adoption call. Tom Petch basically wrote in an objection, but it seemed to be a manageable objection about the prefixes to some of the names. And Jürgen Schoenwalder had many comments, including this comment about the status. But just checking here. Oh yeah, Vlad. I've done a little summarizing here already, but I'd be glad to invite you to the microphone to add some additional detail.
Hi, do you hear me?
Yes, I can hear you.
Yeah, I think the summary that you did is precise, and I don't think we can add a lot right now. The comments from Jürgen are something that the work group can work with and decide upon. Tom's objection was, as you said, manageable, and I think also the work group will have the say about if we modify the prefixes further. But at least we have two people that have read the drafts in detail, and I don't see any explicit support, anyone who has done that, so that's a bit unfortunate. But I think a lot of people have read the draft and no one has come with some obvious objection that proves this draft not to be a working group item. So this is positive. That's what I have to say.
Good, thanks. I appreciate you joining us today to add that. And so then the next question I want to talk about in particular is this idea of changing the status to standards track. I have to agree that if we're going to have a Yang model, as Jürgen said, then it should be a standards track model like the rest of the Yang models. And the big surprise here is that we've never produced a standards track document in the benchmarking methodology working group. That's because all we've produced up to this point is, considerations drafts and terms and definitions drafts, terminology basically, and then methodology drafts where we talk about the procedures and so forth. But there was, at the time the benchmarking methodology working group started, there was no real way to move material like that along the standards track. That's no longer necessarily true, but we haven't had much interest in following what the IP performance metrics working group did, which is to test implementations of the RFCs for their measurement equivalents. Back when we were working on that heavily in the IP performance metrics working group, I opened that possibility up to this working group and didn't get a lot of takers. So we've continued on with the informational drafts. So I'd like to propose two things, and that we're discussing the adoption outcome now. I think it's clear that we need a Yang doctor to work with us, work with BMWG on this. And that's a question for Warren, really. Do you agree, Warren, that that would be helpful, and maybe you can help us get a Yang doctor assigned?
I will try and find a Yang doctor. I mean, if anybody in the working group is already somebody who has a lot of experience with Yang, maybe they can be the initial person, and then I can also try and find somebody from OPS-AWG or Yang doctors to help out.
Yeah, so I think that's one of the problems, that we don't have a lot of Yang expertise here in BMWG, and so we should at least have a like a Yang doctor to advise. If given that the comments that came back in adoption were very specific Yang comments, and not so much on the benchmarking aspect, which those of us who have looked at it seem to be okay with. So we need this additional perspective, I think, and so that's one part of this, and I think we should probably do another short working group adoption call, specifically mentioning that this is that this would be adopted as a standards track document. So that would then be the question, another question for the working group. So any comments on that?
I agree with that. That a new call can be started.
I'm sorry, Vlad. I missed. I think I missed what you said there.
Yeah, I agree with you that a new adoption call needs to be started, so that the formal part of it is met, because this one was for informational. So I agree with that.
Okay.
And this is Warren. I had a quick skim of the charter, and I don't see anything that says that we can't do standards track, but we should triple check that.
Yeah, I think that's true. I've never used that terminology in the charter, although I think I've said a number of times in the document Shepard's form that BMWG has only produced informational documents so far. You know, I just basically have to stop saying that in the in the Shepard's form. That's all. All right. Well, then, given that we, I think the Yang doctor part of this is important. So, I mean, alongside the new working group adoption, should we cross-post this adoption call to another working group to try to get a Yang doctor to help us? Like, I don't know, NetMod?
To CC OpsAWG and I guess NetMod, I guess. But there is also the Yang Doctors alias, which I think is just Yang-Doctors. And if we CC that, that would probably also help. But I can also just ask Robert to please find us a Yang person to help.
Yeah, yeah. And that last one was CC Yang
We'll
for the doctors.
-doctors, but I will check. Okay. And I will put it in the chat.
All right. And Robert. All right. All right, very good. Area working group, right. Oh, okay, so there's some chat here that I've been missing. Sarah says, I also agree. I thought our charter had at one point said something about information, but maybe I'm wrong. All right. So good. All right, and we've got some other things here. Yeah, mailing list, Yang doctors. Very good. Let's see, I'll copy that out of there and post that in there. Good. All right. Cool. All right, so we've got a path forward, and I'll start the working group last call and CC all these people as quickly as I can, and then we've got a good decision about this. I'm sorry for the delay about this. You know, coming to a closure about the first adoption call, Vlad. You know, too many notes, but thank you for your input and participation. Much appreciated. All right. And we're up to 26 people now. I note that's a good thing. So, okay. So let me go back to the slide sharing mode here. Guess I got to stop this, and I'll start this. And I'm warming up to show your slides, Gabor. So please get ready on your end.
Thank you. Can you hear me?
Yes, yes, I can hear you very well.
So shall I begin?
Yes, please do.
Okay, so thank you very much for the opportunity to present this draft. And this draft is about the benchmarking methodology for stateful NAT XY gateways, where XY means 4 or 6, as you want. And the specialty of this draft is that we also consider the pseudorandom port numbers. Could you go to the next slide, please? So I presented the draft at the last IETF meeting, and now I would just give a short reminder for those who were present and a very short introduction for those who were not present. So this methodology works with any IP versions, but for easy understanding, I used IP version 4 addresses. And in this drawing, you can see the tester and the device under test. That's the general test setup from RFC 2544. However, the situation now is a bit more complicated because you can see that on the left side, they are private IP addresses, and on the right side, they are public IP version 4 addresses. And of course, if the tester from the left to the right would like to send some test frames through the device under test, it's no problem. It can use any port numbers and just send the frame through. And it's the duty of the device under test, the stateful, let's say, NAT4 for gateway, that it performs the translation, changes the, let's say, the source IP version for address, and if necessary, it also changes the port numbers and sends out the frame. And of course, the tester on the right side will receive the frame all right. And if it was a frame belonging to a new, not yet seen session, then the device under test store the session in the connection tracking table. And when the tester receives this frame, it also extracts the IP addresses and port numbers, and it also stores the 4 tuple, I mean the source and destination IP addresses and port numbers into its state table, because when it would like to send a frame in the reverse direction from right to the left through the device under test, it just cannot invent arbitrary port numbers, but it has to use a valid 4 tuple and of course change source and destination, and then it can send a test frame through the device under test, which belongs to an existing connection, and thus the stateful NAT gateway is able to translate its addresses and port numbers and forward back. So this is how it works. And so you have seen so far one thing, that the right side of the tester just may not invent port numbers, but has a knowledge in a state table about the port numbers which can be used. And there's another thing, it's in relationship with RFC 4814, that it recommended the usage of random port numbers. So even from the left to the right, you may not just use arbitrary number of port number combinations, because it would have been a denial of service attack against the connection tracking table of the device under test. So we have to limit the port number ranges, both the source and destination port number ranges, to a smaller range, so that all the combinations should be a limited number and not exhaust the connection tracking table. Could you go to the next slide, please? Thank you. And how a measurement happens. So we invented a preliminary phase, which happens before the real test phase. And in this phase, the left part of the tester, which was called initiator, sends preliminary frames through the DUT to the right side of the tester. And 2 things happen during this preliminary phase. The connection tracking table of the device under test is filled with valid connections, and also the state table of the responder part of the tester is filled with valid 4 tuples. And after that, there may come a real test phase, but it's not always the situation, because if we would like to measure the maximum connection establishment rate, then we just use the preliminary phase, and we just make a binary search to find the highest rate at which all the test frames which initiate a new connection are forwarded and successfully arrive back to the tester. And of course, our traditional tests, such as throughput, frame loss rate, etc., are done in the real test phase, which must be preceded by a preliminary test phase. So this is the measurement method in short. And could you go to the next slide? Thank you. So this method was presented already at the last IETF meeting, and since then we have made 2 new versions. Version 01 includes the comments on the mailing list before the last IETF meeting, and version 2 includes some interesting improvement or refinement of methodology, because I have made a lot of measurements for the IP version 6 operations working group for this draft you can see here. And in that measurements, I used an IP tables as a stateful NAT4 for implementation. And I did 2 kind of scalability tests. So in the first test series, I used 1, 2, 4, 8, and 16 CPU cores, and I examined how the performance of IP tables scaled up with the number of CPU cores. And in the second test series, I used a different number of connections in the connection tracking table, and I examined how the performance of IP tables degraded with high number of connections, such as 100 million, 400 million, even 800 million connections in the connection tracking table. And during this experience, I had some more insight how the method should work. And using this experience, we have reworked section 4.3 and made some changes also in 4.4. And as Al wrote a few days ago, I should have changed some other parts, and I will update those parts also because there became some inconsistencies. But now I would like to talk about section 4.3. Could you go to the next slide, please? Thank you. So our experience has shown that there's a significant difference between the processing power necessary for a test frame when it generates a new connection and when it doesn't generate a new connection in the contract table of the device and the test. And what is even worse, we experienced that if I fill the connection tracking table and it requires a given amount of time, its depletion requires even more time. So it's a problem if some connections are time out and some new connections are established during the test, because their proportion may significantly influence the results of, let's say, throughput test and other tests. So for this motivation, I think we managed to make the measurement procedure more clean, and I would like to explain it in the next slide. Could you go to the next slide, please? Yes. So the consequence is that we can ensure 2 extreme situations, and they can be ensured easily. And unfortunately, I must say that I cannot ensure any other situations easily. So the first extreme situation is when all test frames create a new connection. And this is ideal for measuring the maximum connection establishment rate. And the second situation is when test frames never create a new connection. Of course, I understand it for the second phase, for the real test phase. And this is ideal for the throughput, latency, and all other traditional tests. And due to black box testing, I must say that we are not able to ensure other situations in between. For example, it would be natural to say, let's say 10% of the new test frames create a new connection and 90% belong to the existing connection. But I cannot do that because of black box testing. So the tester is not able to examine the connection tracking table of the device and the test. For this reason, I don't see a good chance to implement such kind of tests, just the 2 extremes. Okay, and how to ensure these 2 extreme situations? I will cover this in the next slides. Could you go to the next slide, please? So before the method how to ensure the 2 extreme situations, we make some assumptions. The first assumption is just for simplicity. It is that a single source address and destination address pair is used for all tests. I know that RFC 2544 requires also testing with 256 different destination networks, but currently we do not support it. That could be supported, but for simplicity, we don't deal with that now. And another assumption is that the connection tracking table of the stateful NAT/XY device is large enough to store all the connections defined by the different source port number, destination port number combinations. So it is something to be ensured by the one who performs the test. And if it's ensured, then all other things can be ensured easily. Could you go to the next slide? So, extreme situation 1, which is for measuring the maximum connection establishment rate, is that we need to ensure that all test frames initiate a new connection in the connection tracking table. So it just for the first phase, the preliminary phase, and it's very easy because we must use all different source port number, destination port number combinations in the preliminary phase, and we also need to ensure that the UDP timeout of the gateway is higher than the length of the duration of the preliminary phase. Of course, if some connections would time out, the new combinations would still result in new connections, but we must ensure that no connections time out, because the timing of the connections would impose some processing power need. So we would not like to disturb the measurement with some timeouts and deletions of connections. That's why we need to ensure that connections are not deleted. And this is enough for the measurement of the maximum connection establishment rate. Could you go to the next slide? And now comes the most interesting thing. We would like to perform the traditional measurements such as throughput and frame loss rate and latency, etc. So how can we do that? These are the conditions. So in the preliminary phase, we use all different source port number, destination port number combinations, and in the preliminary phase, we enumerate all possible source port number and destination port number combinations. Of course, there's a range for source ports and destination ports, and we determine the ranges that all the combinations can be exhausted, so no more combinations remain. For this reason, in the second stage, in the real test phase, no more new combinations may occur. And of course, we must set the UDP timeout of the gateway to a value higher than the sum of these three values here. This is the length of the preliminary phase and the gap between the two phases and the length of the real test phase. And if we ensure that, then in the real test phase, we will have no new connections, no timeouts, and all test frames will belong to existing connections. So it makes testing more simple, because this spring, when I made some other tests, I had to take care if things will time out or not time out, and refresh the connections by periodically scanning the connection, the state table of the device of the tester. But now this high timeout eliminates all other troubles, and I think in this way these two measurements, these two types of measurements, can be executed in a way that they produce, I think, meaningful and especially repeatable results. So could you go to the next slide? Thank you. And of course, some considerations regarding the pseudo-random port numbers. Earlier, I have made also some tests when I enumerated the port number combinations in increasing order. I mean that let's take the source port and destination port numbers and make a 4-digit number, and of course there are some valid and invalid combinations. I just enumerated the valid combinations in an increasing order. But I experienced that when I enumerate all the combinations in a pseudo-random order, and if I enumerate them in an increasing order, the result is not the same, and it's probably some special things in IP tables, but I experienced that there was a significant difference. So pseudo-random enumeration is a must, and of course we may use linear increasing enumeration, also an arbitrary metric, but pseudo-random enumeration is a must. And of course there's a good algorithm for that. So we can use Duttenfeld's random shuffle algorithm. It means that we just enumerate all the port number combinations in an array, and then make the random shuffle, and then we have all the port numbers, and during the test we just read the array in the tester. So I have implemented that. It works perfectly. It's just a few seconds before the real test, and then may come the real test, and it works good. So that's all. And if you go to the next slide, I will have some questions there. So far I have told what we can do. And my question is, what do you think about it? So do you think that it is a useful thing? Do you think that they provide meaningful and reasonable results? And are these results satisfactorily characterize the performances of the device under test, or is there anything missing? And I have a first question. What do you think about measuring the connection teardown performance? Unfortunately, I can offer only a way that I fill n number of connection in the connection tracking table, and then I delete the entire connection tracking table. It can be done with IP tables by deleting the IP tables rule and then removing the kernel module, or it can also be done with Joule, which is a NAT64 implementation, by restarting Joule. And we can measure its time. So I have experienced that it lasted longer than filling in the state table. Sometimes it lasted for minutes when I used a high number of connections. So it's enough to just measure the aggregate time of n number of connections, deleting them. I don't know. So thank you very much for listening, and I'm very curious of your opinion or suggestions, anything.
Okay, thanks, Gabor. I'd like to open it up for questions and comments at this point. I think you've brought us up to date, and you've got reasonable requests for feedback here. So let's hear some feedback on this, on your work that is pretty fundamental to the kind of thing we normally do in benchmarking methodology working group. Okay, I don't see any requests for the floor. So Gabor, maybe there would be more. Are there any backup slides here where you showed the results or something like that?
Well, if you think about the measurement results of the IP tables testing, I have some slides. I intended them for the IP version 6. How would I say? So the other meeting, but I have some slides here. I just try to find them. So benchmarking stateful slides. Yeah, it's here. I hope they are. No, it's not that. Sorry. I'm sorry. IP version 6 transition scalability slides. Yes, I think they are. No. I'm sorry. I just can't find my slides, but anyway, I will be able to do that. So I have uploaded I don't know. Okay, I will find. I set it to Fred Baker, the other slides, and I will find it here. Yeah.
All right. And
Yes.
I'm kind of assuming that you'll be able to, that I'll be able to allow you to share your screen at some juncture here. But otherwise, I can try to find the something that you sent to the mailing list which will allow me to share, like kind of like the text version of this.
So I have got now the file. If I just save it to myself, and I find the slides. I save it here, and yeah, it's in work. Save. Okay, I open the slides, and yes, I need to be able to yeah. No, I'm sorry. Oh, I see the wrong file. Yes. Wait a minute. Yeah. Yes, I got the slides now. I think I would like to ask permission from you to share the screen. Yeah.
Okay, so yes, grant screen. I've given it.
Yes, I do want to share my screen. Select window or screen. I would like to share transition scalability slides. PDF. Hello. Can you see my screen?
Yes. Yes, we
Can
can.
you still can you see? I got it to full screen.
Yes, yes, it's great.
Okay.
Thanks.
So these are the results. I just start with the other one. So you see here the number of cores: 1, 2, 4, 8, and 16 cores. And I measure the number of connection per seconds, median, minimum, maximum. It is in thousands. So it means that 223,000, and here is 2.3 million. So,
and these are the number of cores that are allocated to the to a virtual machine that's doing the NAT function.
sorry?
I'm asking in the case of number of cores, you're allocating a certain number of cores to the NAT processes.
Yes, it means that I use the physical machine, and I just switched on and off the cores. So with a kernel parameter, I could switch on and off the cores.
Right.
So first I measured with a single core, and then with 2 cores, 4 cores, 8 cores, and 16 cores.
Right. Probably something like task set for a list of cores or something like that with a particular process. Okay.
And you can see that it scaled up quite well. So it from 1 core to 2 core. Do you also see my little pointing hand?
Yes, yes, we do.
So from 1 core to 2 core, it didn't double, and from 2 cores to 4 cores, it didn't double, but it significantly increased. And I also calculated the relative scale up. So it's not the double, and at the end, it's not 16 times as more, but you can see it about 10 times more. So it's quite good scaling. And here's the throughput. Also, it didn't double, but similarly, it's about the performance of 10 cores. So 16 cores, I could achieve the performance of 10 cores. So it's not bad, I think.
Right.
And
yeah, so just a question. Was this testing on an Intel architecture where you've got 2 NUMA nodes, something like that?
Yes, it was Intel. I can show you the previous slide. Here it is a Dell PowerEdge R430 server, and the clock was set to fixed 2.1 gigahertz. It is the RAM size, and there were two 10 giga dual port NICs. And this is the operating system internal.
So the Dell BIOS actually has virtualization features. Were those turned on to help out the CPUs here?
Hyper-threading was switched off.
Okay.
And it didn't use any virtualization. It was physical machine.
Mm-hmm.
And
So
these computers had 32 cores, but I didn't include the measurement with 32 cores because there's some kind of problem. Because if I use 32 cores, no interrupts were scheduled for the last 16 cores. So I excluded those cores. I didn't include. It didn't really increase after 16 cores because of that problem. Sorry, what did you want to say?
Yeah, no, hey, first, thank you for presenting results. I think if we were in person, you'd have a line of people sitting in the front chairs, leaning over to see your results. It's always fun when we get these results in the working group. So thank you for sharing them. I am a little surprised to see 16 cores kind of performs at the speed of 10 in your statement that, hey, this is not bad scaling. I realize it's probably not in the purview of the draft. I was just curious as to why you thought that was okay scaling.
It was important for me at the IP version 6 operations group how it scales, because there are some opinions that stateful technologies don't scale well and stateless scale well, and I think it's quite a good scale up. So I did some alternative DNS server benchmarking, and even that was not better. Mm-hmm. But here it is a stateful thing, we have to handle the connection tracking table and how well these CPUs can cooperate on the same connection tracking table. I think it's a really good result. And if you have some time, I can show you some other results. These are the scalability agents, the number of concurrent sessions. So how many sessions are stored in the state table? You see, here's the number of connections in million, and I could test up to 800 million, but it was really the limits of the hardware. When I used only 400 million connections, it was somewhat less than 150 gigabytes, the usage of memory, and it was somewhat below 300 gigabytes, but altogether we have only 384 gigabytes. So in this case, in the last column, you see the results when non-numerical local memory was also used, and there was another limit that I couldn't set the hash table size higher than this one. So this was the highest one. You see that we always quadrupled the numbers because of increasing the port numbers, and I couldn't do it anymore because it gave me an error message. So it works that IP tables has a hash table, and from every entry of the hash table, the linked list is started, and usually the linked list has less than one element, but here it's on average all linked list has 3 elements. So it is a factor which slows down the operation. And of course you can see some degradation, some performance degradation here, but here you can see that the throughput is nearly constant here. 4.4 million, 4.5, 4.5, and so on and so on. It's just measurement error is 4.4, I think. This is the constant 4.5. And here at the beginning, I think the first column is higher because of the level 3 cache. It still could do something. But it means that in a wide range, it's quite scalable. Of course, the price was that I increased the hash table size, and it used a lot of memory. But it was quite good.
Yeah, very interesting. Thank you for sharing this.
Thank you.
Yeah, it's always interesting to look at some actual results, and then we can get a feeling for the value of the benchmarks you've proposed. So that's a great follow-up, Gabor, and I'm glad we took an extra moment or two to get this on the screen and make it part of our meeting. Thanks.
Thank you.
All right. So going back to the questions you raised, I'm going to see if I can hijack the screen here.
I stopped sharing, so you will get back the screen.
Very good. All right. And so I think we can kind of answer this first question now. Do they provide meaningful and reasonable results? In the use case where you've applied them to try to answer a question about the difference between stateless and stateful, I think the answer is yes. And you've got a couple of good metrics there. I think that there's some ability to think about this more. Yeah, I think in my comments I was wondering about the size, whether the size of the table itself was a metric that was worth measuring. Is the table capacity, is that one of the ones that you've proposed?
Yes, it's a good question. As I could set the size of the connection table in case of IP tables, so it was not interesting for me to measure it. But I have a little experience with Joule. My student works with that, and we couldn't find any way to set its connection tracking table size. So it may be an interesting metric. And yes, we can measure it, but it's not very easy. You saw that as I knew that its size was large enough, I could be sure that if I try to add new entries, and the problem can only be that I do it too fast, and this is how I could measure the maximum connection establishment rate. However, if I don't know its size and I don't know its maximum connection establishment rate yet, then there are two good reasons to fail a test: because I do it too fast, or because the table is exhausted. So I have to be tricky to measure both, or just one and then the other. But I think it's reasonable and it can be done.
Yeah, at least you can report the number of connections that you've used during a test, and in the follow-up testing. So that's at least you can infer something about the capacity there from that. Okay. And oh yeah, connection teardown performance. So then you're working with timeouts again, and the efficiency of connection teardown in the device. I think it's reasonable to look into that, but I can certainly imagine some difficulties trying to make a repeatable benchmark out of it. What do you think, Gabor?
Yeah, the trouble is that I'm not sure if how many of them times out and how many new I should include. So it's what I can do easily is that I drew a first phase and I just input a lot of entries, and then I just finish the measurement and I call something which destroys the connection table. In case of IP tables, I can just delete the IP tables rule, and I can remove with rmmod Linux command the kernel module, and then it lasts for a long time, for minutes, to execute the command, and I can measure its time. And of course, I can do the measurements with different number of connections, and I can estimate how much work on average to destroy one connection. I'm not sure how much, if it is good or not.
I see, and that manual deletion of the entire table is it should be a process maybe similar to the timeout process, But it's kind of surprising. I get maybe not so surprising when you've got, you know, connections in the sizes that you're talking about here, and you know, really large numbers. So in any case, that's a it's just something to think about. I can see that you're already thinking about it, and you know, if you try some things and there's something useful comes out of it, I think that's worth investigating, because it is, you know, it's the other side of connection establishment, and that feels good, feels symmetrical to understand both.
Yes, and of course, because I didn't make a sure measurements, but it seemed to me that it was even slower than establishing the connections. So it's significant. So if you are an ISP and you operate a gateway, then new connections are coming and some connections are deleted, and it matters how much effort it takes to delete a connection.
Right. Right. It seems like if you filled, well, yeah, if you knew the capacity of you have to know the capacity of the table, and then you fill it, and then you wait a certain amount of time where a number of the connections should be number of the first connections established should be cleared, and then you know, it should have timed out, and then you try to establish a whole new block of connections and determine whether the device is ready for those yet, or things along those lines. It seems to me that we've had some testing like this proposed, you know, of this ilk proposed in the past, and I'm not connecting it to a particular RFC that we did, but I'm sure that there's one out there where we had to grapple with this. So anyway, that's something to think about too. And yeah, so far I think the aggregate measurements are a great start here, and as you say, can't do anything else. But the depletion time is that might be an interesting thing to investigate further. Okay. Well, thank you, Gabor, for your talk. I just wanted to quickly summarize that in the May-July period, I saw 5 people discussing the draft on the list. There was, you know, the references to the procedures in RFC 8219, which our friend Marius worked on, I believe, right? And also there was sort of some interest in the TCP-based testing, and that was you know, something that was talked about. But right now you're all UDP, and I think that's probably a good scope for now. I guess the question to the group is, with the list traffic that we've seen and the reasonable results that we've seen, and actually the open source implementation of some of this that Gabor has prepared and made available to us on several occasions. What do people think about possibly adopting this draft as a working group item? And I'm looking for feedback from the group. Who's read the draft? Anybody read the draft? Besides me? All right. Well, among the folks that read it, there was pretty good support. Unfortunately, we don't have them here on the list here today. So, well,
Hey, Al?
yeah, Sarah, go ahead.
I think it's Gabor. I apologize. I hadn't had a chance to go through this in detail, but I will take a look. And frankly, between what had piqued my interest to put it on the reading list, and I'm running out of time, and this presentation today, I do think it's worth asking the working group for the support. And I would also, I mean, I always read the drafts, but I just wanted to weigh in officially and say thank you for doing this. Thanks for presenting the results. And I will absolutely read it formally and share my feedback with you on the list.
Very
Thank you very
good.
much
Thanks,
for that.
Good. All right. Well, I think what we'll try to do is now ask any volunteers to read the draft in the next month or so. Okay. Well, then we'll try to ask that same question on the mailing list, Gabor. I think you're basically doing a good job of that. And if you have some more results to share with us, that may help get some commentary going. And I would share these questions on the mailing list as well as a kind of a prompt for folks to read the draft. And then maybe we can, depending upon what happens in the remainder of November and December, we can maybe take up a working group adoption call in January or sometime in 2022. Is that a good solution?
Thank you very much for that. And I'm very happy for your willingness to do that.
So reviewers in November and December, and then possible in 2022. Yeah, that's good, because this is the kind of thing that's right up our alley. It's very obviously very benchmarking centric, and your work here to advance our state of the art is very much appreciated. So thanks. Okay.
Thank you.
Very welcome. All right. So the last topic today is a brand new topic. It was proposed by Zeki Lai and his co-authors, and I'm going to share some slides here, which were prepared for this talk, and you can all read the title of the talk here with me together: Problems and Requirements of Evaluation Methodology for Integrated Space and Terrestrial Networks. So we're going to learn a lot about this today, and I really thank Zeki and his co-authors for bringing this to our attention. But I will say one thing in advance, and that is that our work on benchmarking is limited to what we can do in the isolated test environment, and that means that we're obviously not going to be running any benchmarks over satellites. At least the things that we kind of create here. But and I'll say more about this at the end. I'd just like to think. I'd like folks to think about as Zeki Lai describes this work, what kinds of pieces of it we might be able to tackle in the near term within our charter, if anything, and if more development or research or other activity is needed, then let's try to figure out what those things are and give that feedback today. But with that, Zeki and his co-authors are all new to the working group, as far as I know. So welcome, and you can begin your presentation.
Okay, so thank you very much, Al, and thank you in advance for controlling my slides, because maybe in the next presentation I may continuously say next page. Okay, thank you in advance. So Hello, everyone in the BMW folks. Good morning and good afternoon, and maybe good night for myself, because this is about 1 a.m. in my place. So this is Zhe Lai from the Institute for Network Science and Cyberspace, Tsinghua University. And this is my first time to participate in the online meeting of our benchmarking working group. So today I'm going to introduce our draft talking about the problems and requirements of evaluation methodology for integrated space and terrestrial network. So next page, please. Okay, so first let's get started with the background and motivation. So recently we have witnessed a renaissance in the space industry, and it stimulates an explosional growth in constructing new space mega constellations. A number of companies have disclosed efforts along these lines, including SpaceX, Amazon, OneWeb, and so on. So these mega constellations are proposed to provide global internet service. For example, Elon Musk sent the first tweet through the space via Starlink satellites. And recently, Google said that it signed a deal with SpaceX to use the space company's growing satellite internet service, Starlink, with its cloud unit. SpaceX will also install Starlink terminals at Google's cloud data centers around the world, aiming to utilize the cloud for Starlink customers and enabling Google to use this satellite network's speedy internet for its enterprise cloud consumers. As of November 2021, there are already 4,500 active satellites launched in the orbits, according to the UCS satellite database. So look at these two figures. As of the USA has about 2,700 active satellites, and China have about 400 satellites, and the United Kingdom has about 340 satellites. And we can find that most of these satellites are from mega constellations for the internet service. For example, this figure, the right down figure, Starlink has launched its first share of phase 1, which consists of 1,600 satellites in low Earth orbit, which we mean LEO. Next slide, please. So with such plans in progress for large-scale satellite constellations to provide global internet service, the internet is potentially taking one giant leap into space. What might the internet be in the next decades? The future is up in the sky. Here are our understanding for the internet in the next decade, which we call that integrated space and terrestrial networks, or ISTN. At a high level, the ISTN will contain two segments. The first one is the space segment, including satellites and ground stations. Here, the LEO stands for low Earth orbit, which means less than 2,000 kilometers orbital altitude. Emerging mega constellations like Starlink, OneWeb, and the Amazon Kuiper work in LEO. The second segment is the terrestrial segment, which include the network infrastructures of today's terrestrial internet. Taken together, ISTN can provide internet service for various users, such as space-based users and traditional terrestrial users. So next page, please. The integration of satellite constellations and terrestrial network opens a lot of great new opportunities. The first one is that ISTN can potentially provide pervasive network accessibility for various users. According to a recent report from Statista, the global internet penetration rate is only about 60%. There are still a large portion of population still have no internet access in the world. ISTN is promising to provide internet access for remote or rural users and many other situations like maritime, global IoT, airplane users. In addition, ISTN can also be used for many new scenarios such as space flight, deep space navigation, and exploration. So next page, please. The second, ISTN can provide low latency for wide area long-haul communications. The low latency opportunity is based on two important facts. First, emerging satellites can be equipped with inter-satellite links. For example, the free space laser links for inter-satellite communication. Laser links can communicate at the speed of the light in a vacuum, which is much faster than that in the terrestrial fiber. Second, evenly distributed LEO satellites can establish near to optimal space routes and enable lower latency as compared with meandering terrestrial fiber routes. For example, this right picture shows an example. On one hand, assume two communication ends locate at Beijing and Sydney. For some ISPs, if you use the trace route to track the packet forwarding, we can find that the packet might first be forwarded to Los Angeles and then to Sydney. On the other hand, if we can use LEO satellites with inter-satellite links to create a space routes, like the green line in this figure, we can obtain the near to optimal path with reduced latency. The next page, please. And the third opportunity is that ISTN can enable high throughput access. Free space high-speed inter-satellite links can provide several Gbps data rates. And the new Ka or Ku radio frequency links can also provide very high-speed ground station links. So this picture shows a speed test from the individual Starlink beta test. So one individual user can obtain about 400 Mbps downlink data rate over the current version of Starlink constellation. Next page. But while promising, ISTN also involves several unique characteristics that might be the roadblocks of realizing such new opportunities. The first characteristic is the high dynamics on a global scale. These two figures show the first share of Starlink constellation with more than 1,500 of satellites. This satellite moves in very high optical velocity, and it takes about 90 minutes to make a one pass around the Earth. That means the space-ground connectivity could change in about every 3 minutes. Such dynamics may cause many for example, connectivity loss, routing reconvergence, and other issues. Next page. The second characteristic is that mega constellations are still under heavy development. There exists many unknown or unexplored uncertainty in the architecture, mechanisms, and protocols in future ISTN. Just like this draft we propose, maybe the version is awful, so we need many rounds to discuss and modify our draft to polish it. And the Starlink constellation today is not the same as its first version, and we believe it is not the final version, and it will still evolve rapidly in the future. The next page. Finally, as compared with many other kinds of the terrestrial network, the operational cost of a satellite network could be very high. Here I got the cost, I mean the time and the money. For example, it may take years from a contract to the real satellite launch, and if we have deployed the satellite in outer space, updating a deployed constellation is costly. So next page. So here, when we look back at the history of the internet, we can find that evolution and benchmark play an important role in the evolution of our internet. If we look ahead, since ISTN is still evolving very rapidly and not in their final stage, we argue that ISTN necessitates the right evolution methodology. There should be many new designs and internetworking technologies in ISTN, such as new constellation, new architecture, new topology, new routing mechanisms, and new transport and new applications. Next page. Because there are many uncertainties and the operational cost of satellite network is high, so such new network designs are expected to be comprehensively and systematically evaluated before they are deployed and launched to outer space. Next page. And here, when we talk about the evaluation methodology, first, we need to create an experimental network environment or a laboratory environment. Second, we need a series of recommendations of benchmark or test case to be run in the laboratory environment. and again implications for the tested inter-networking technologies. Next page. Thus, we ask the question, how can we evaluate such new inter-networking designs for future ISTN? So next page, please. So next, let's look at the possible evaluation methodology. The first one and the most straightforward approach is to leverage live satellite networks to evaluate new designs. For example, Starlink has started its beta test recently. However, this approach suffers from several limitations. First, the live satellite network lacks the flexibility to explore the various experimental requirements. For example, it is very difficult to change the constellation, change the inter-satellite or ground satellite connectivity to evaluate various inter-networking technologies of ISTN. Second, the accessibility of a live satellite network could be constrained in many regions around the world. As far as I know, for example, the Starlink beta test is only available in certain regions around the world. Finally, directly conducting experiments in a live network has many constraints. For example, it is difficult to conduct the topology or routing test in a live satellite network. Next page, please. The second approach is using simulations to evaluate or benchmark new designs for ISTNs. Both the aerospace and network community have many simulation tools to create an experimental network environment for evaluation. For example, STK is a representative orbital analysis tool that can perform complex analysis of spacecraft as well as ground stations. However, STK mainly focuses on orbit and spacecraft analysis and have the limited support for simulation of inter-networking technologies. More recently, SNS3, Hypertier, and StarPerf are emerging simulators for ISTN. So SNS3 is an extension to the NS3 simulation platform, and it models a full satellite network with a geostationary satellite and bandpass payload. Hypertier is a framework for simulating and visualizing the network behaviors of emerging megaconstellations. Similarly, StarPerf is a simulator that enables users to characterize, estimate, and understand achievable network performance under a variety of constellation options. Although the above simulators can flexibly simulate satellite characteristics and the impact of dynamics of network conditions, a fundamental limitation of those simulators is that they cannot support run of real system codes or functionalities as in real deployments. The abstraction level of pure simulators might be too high to capture the system level effects and could hide other practical issues, for example, software overhead under the heavy workload in real systems. Next page. So the third approach is emulation. Emulation is a hybrid approach that integrates real applications, protocols, and operating systems in a network environments. Similar to the live networks, emulators run real codes with interactive network traffic. Similar to simulators, emulators can support controllable and diverse topologies, and their virtual hardware requires less resource as compared with live networks. The community has many private efforts such as mininets and other VM or container-based emulations. But the limitation is that existing emulators inherently lack the ability of mimicking LEO dynamics and time-varying network behaviors in ISTN. For example, the high dynamics on a global scale, and they cannot incorporate the unique characteristic of emerging mega constellations. Next page, please. So once we have set up an experimental or laboratory environment, next we need the right test case for the evaluation. The IETF has many discussions and standards related to the benchmark cases for a specific application or network. For example, as plotted in these slides, it shows for example, the document about the test case for evaluating congestion control for interactive real-time media, or the evaluation test case for interactive real-time media over wireless networks. And also we have some benchmark test cases for data center networks. But collectively, the limitation of these test cases is that they mainly focus on terrestrial networks and do not, maybe not so suitable for the ISTN, as they do not incorporate the unique type dynamics of ISTN. Next page, please. So given that all these existing approaches have their limitations on evaluating ISTN, here we summarize the problem. Existing evaluation methodologies from both the aerospace and the network community may have their limitation and are insufficient for comprehensively and systematically evaluating ISTNs. Next page. So what we also ask the question, what are the requirements of the right evaluation methodology for ISTN? So next page. Here we conclude, by our understanding, several key requirements for ISTN evaluation methodology. Next page. The first requirement should be realism, at least constellation and real network realism. That means if we create an experimental environment or an isolated environment in our terrestrial laboratory, the terrestrial presentation is expected to have the same scale and dynamicity like a real constellation. For example, in an experimental environment for Starlink satellite network, it's expected to have the same size of the experiment nodes. For example, the first shell of the Starlink phase 1 has about 1,500 satellites. So if we build a virtual presentation on the terrestrial environment, it is expected that this network environment can include, for example, 1,500 network nodes. Also, it is expected that the environment can load realistic network traffic, functionalities, protocols, not just a numeric simulation. Next page, please. So the second requirement, we call it flexibility at mega constellation scale. Testers may have various experimental requirements to evaluate various inter-network technologies under different network architectures, topology, and so on. So the methodology is expected to flexibly support various experimental situations. In addition, consider that the scale of mega constellation network could be much larger than many other terrestrial networks. For example, a satellite network could be a global wide area network with thousands of network nodes. So the methodology is expected to be scalable to mega constellations. Next page. And the third requirement could be maybe low cost and easy to use. To advance the progress of ISTN technologies, the methodology is expected to be technically and economically feasible for normal researchers and engineers. Next page. And the last one is that the methodology requires realistic data and test cases to improve the fidelity and standardize the benchmark steps. For example, if the evaluation is driven by realistic constellation information and ISTN traffic, user and ground station distributions, it can produce more meaningful recommendations concerning the key performance characteristics of inter-networking technology. Next page, please. So here, if we look forward, what we really need is an evaluation methodology tailored for ISTNs. And how could we design such an evaluation methodology satisfying all the requirements above? A viable path might be to build an integrated realistic database, community-driven evaluation methodology for future ISTN. Here, the integration means that we can combine live facilities, simulations, and emulations together to conduct flexible and low-cost experiments with acceptable fidelity. Data-driven here means that the laboratory environment is expected to be driven by real data, for example, based on information of real ground station, satellites, orbits, and constellations. Here we show these three pictures show introduce some open database. For example, this is the satellite database of ITU and NORAD. In this open database, you can search the satellite information. For example, the satellite location, latitude, longitude, and altitude. This figure shows that the right figure, the third figure here shows SAT NOGS, which is an open platform for ground station networks. Users may purchase a small ground station or satellite dish and participate this platform by sharing their ground station data or results to other participants. So the third feature might be crowdsourcing, or we can call it community-driven. Essentially, ISTN is a wide area network, not a private local area network. So creating the right evaluation methodology for ISTN needs the collaboration of the community. The evaluation methodology of ISTN requires efforts from participants from different regions to share or contribute their test cases and the results. And also, we need the participants with different domain knowledge. For example, the knowledge from both the aerospace industry and the network community. Next page, please. If we continue to look ahead, who can benefit from such an evaluation methodology? For satellite operators such as SpaceX or OneWeb, they can use this evaluation methodology to analyze and understand network performance under various constellation designs. For example, under different numbers of satellites and the different orbital heights. Second, for internet service providers, they can use such a methodology to evaluate the reliability, latency, throughput, convergence time, and other metrics under various inter-domain routing protocols. Third, for content providers, they can use this methodology to assess the various congestion control mechanisms on the network fluctuation, which may involve non-congestion RTT variation and packet loss in ISTNs. Also, we ask a question: what can be standardized? Here we conclude maybe first the evaluation methodology for ISTNs and the benchmark steps and test case, and also some maybe the performance metrics for ISTN evaluation. For example, the constellation utilization can be standardized by the draft or work. So next page, please. So next, this is a conclusion page. So let's conclude this presentation. Future integrated space and terrestrial networks, or STN, hold great promise for pervasive, low latency, and high throughput internet service. But realizing such promise needs the right evaluation methodology to comprehensively and systematically evaluate and understand new network designs for ISTN before the real deployment and launch. Existing assessment tools or benchmark tools, platforms, and test cases are insufficient for comprehensive and systematic evaluation for ISTN, and we need the right evaluation methodology tailored for the future ISTN. For example, the constellation and network realism, flexibility, low cost, and data trace and test case. So that's all. Thank you. And any questions, recommendations, suggestions are more than welcome. Thank you, and thank you, Elle.
Well, thank you, Zeki. You've run through this very efficiently, and all your references are available here.
Yeah.
So we've got all that material available, and this might be a slide to leave up for folks to kind of refer to. Let me open the floor up to comments, and if folks have any questions or additional observations they'd like to make. Maybe we've got some satellite low Earth orbit system users out there who'd like to comment.
Mm-hmm.
Well, I am definitely not qualifying into the latter part of Al's comment there, but I would ask, first thing, this is super interesting. I'm wondering if you have any participation from operators or folks who are running these satellites or ISTN networks, for lack of a better term here. Do you have any involvement from folks outside of the educational forum?
Okay, thank you, Sarah. Thank you for this question. Actually, our team have been working on the ISTN for many years, and as we have listed in the reference page, so over the past decades, maybe we have some research work and from paperwork, or we also submit some discussion or draft in the standard group, for example, IETF or ITU. And for your question, I mean, today, maybe most of our work are done by our groups, but in the future, maybe if we can agree, this is a very, after we clarify these problem statements and requirements, if it is needed, we can ask for some further collaboration, maybe with the satellite operators or maybe the cloud operators and the industry, satellite industry. So we can leave it as our future work.
Mm-hmm. Yeah, I definitely see. I definitely see some room for clarification here, and we can provide those comments to you on list. Right? There is a very high-level view of requirements, but I think getting to the next level down and merging some of what you said into text would make a lot of sense. And then I think once there's sort of a cohesive, hey, here's what we want to do, and here's particularly what we want to measure and why the existing RFCs that we have don't cover those methodologies. And you've touched on, I think your first bullet point there under looking ahead for satellite operators is a really interesting one. I think then based on what I know today, ahead of the working group taking this on, or us having a conversation around if we're the right ones to take this on, would definitely be around, hey, making sure that there's a need for this in the industry. And it certainly seems like there is, but getting that feedback directly from the folks who would own these satellite or space networks, I think is probably going to be key, so that we understand, hey, putting the time into this makes a lot of sense. And again, that's, I think, a secondary point to, I think there might be a bit of a question there over whether or not we're the right group to do this or not. Benchmarking, yes. It's the first bullet point on that previous slide that you were on around, hey, where the satellites are positioned at. Once we start getting into space-specific technologies, it makes me wonder if maybe this is very interesting, very cool and neat, but maybe a little bit beyond our depths of current charter, or potentially even the charter that, I'm not sure if the IETF itself could take this on. But I to be clear, what I'm proposing is, hey, if we have a crisp and clear set of problem statements and the requirements that what are you looking to test and measure, and why what we have today doesn't help? I think once that's crisp, it'll be easy to have, or what I propose is then we could have that conversation around, does this make sense for us? Or if you can remove certain things out of scope, would it make sense for us? Al, I was thinking ahead a little bit there to, hey, if they want to test, where satellites, how closely they're positioned or not, or what have you, that's probably way beyond our purview. But if they remove that from purview, or make it sort of a superfluous detail, would that change our stance? And I honestly don't know. I could take a guess, but I'm proposing that, hey, we might want to have that conversation as a group.
Sure. Yeah, the reason I put this slide back up is that if you take away all the indications that things are flying here and Earth stations, there's some fundamental networking problems to solve, and that is that there are, you know, backbone satellites and relay satellites, and you can think of these as backbone routers and maybe routers near the edge but not quite at the edge, and then, you know, you've got the terrestrial network here where there are going to be routers that are connected to the Earth stations that are at the edge of the network, and there's, you know, there's real path benefits, that path length propagation delay benefits that can be derived from the additional flexibility that a dense LEO network can provide. So there's clear advantages to to this work on paper, from many perspectives. But as Zeki Lai mentioned, there's also a lot of expense involved in building these networks and maintaining these networks. The maintenance part is hard, because these satellites are in space and they can't be easily serviced beyond a kind of like a reboot that brings online redundant equipment, things like that. So it's a cold, lonely problem to try to fix these things, and the satellite processors in space. I think Zeki, it might help a little bit for me to add my personal perspective here. I spent the first 8 years of my career working in satellite communications.
Oh.
And back then it was the late 70s and the early 80s, and so satellite communications was a lot simpler.
Yeah.
And if we involved, pardon?
No. I say that the first generation satellite network is mainly based on the geostationary satellite.
That's right. But I think the most important part of it was that we found ways that we could test the satellite network in the laboratory without some of the pieces. Let me just put it that way. We had a laboratory where we could test all of the ground-based systems and the and the networks that connected up to the satellite network, and all of the frequency conversion. And then maybe the big surprise is that we had the actual what they called the brass board version of the satellites. And so we dispensed with antennas and high-powered amplifiers, but we connected right up to the functional satellite with using waveguide, and that was a very valuable thing to do, because very often most of the questions we were asking had to do with how many channels can we get going on this satellite with this new form of modulation, and so forth. And finally, we did bring in some antenna-based testing with the third generation of the satellites that we tested. We ended up with two big brass board versions of the satellites there, with a traveling wave tube and silicon-based amplifiers. The technology changed over time. It was, all I'm saying is there were ways to scale down from the complexity of actual satellite live network usage and still get very meaningful results. So that's the challenge that we would be faced with here in trying to get this working in a laboratory and in a benchmarking kind of environment that we could call on. And maybe that's the kind of thing that would only answer a limited range of questions, but it still might be useful to go after that. So you could imagine, I've been thinking about the dynamics of this here, the dynamics of the multiple shells of the orbits that are talked about. I mean, all the orbits you're talking about are higher than the International Space Station, and the International Space Station is at 220 miles, about 330 kilometers or something like that, and it traverses the visible sky in less than a minute. It really seems to fly by. You're talking about the low Earth orbit with 3-minute visibility. So that's, I mean, that's actually a big step up. You could potentially use, you know, one satellite for 3 minutes, and that starts to give you the kind of you know, the pace of connection changing that's going on. Also, I attended a workshop back in September, and at the end of the workshop, one of the participants who'd been, you know, very active, very vocal, and you know, really nice guy, he revealed to us that he was using a LEO satellite service. And yeah, we did see a couple of interruptions when he was speaking and things like that, but no more than what you see when you know, when somebody's trying to use the terrestrial background. So I thought that was quite amazing. He walked around the farm where he was and showed us the dish up on top of a barn and stuff like that. It was really cool. So yeah, this stuff is a reality right now. That's the most important comment I wanted to make. And it's just a matter of designing the right you know, a scope of testing that would produce some meaningful benchmarks and reasonable results, I think. And I'm you know, we're getting close to the end, so I'll give you the last words here, Seki.
Okay, thank you, Al, and thank you, Sarah. Thank you very much for all your comments. So I want here maybe let me explain why we want to submit this draft, because during our previous studies in the ISTN, we found that there are a lot of internetworking technology and challenges facing the ISTN, because as we have introduced before, the high dynamics and the constrained resource and the high operational cost. So if we want to unleash such a lot of potential of the ISTN, for example, pervasive connectivity, low latency, and throughput, we need a lot of new research. And we know the experimental or the evaluation methodology play a very important role during the evolution of our internet. So we believe the same thing for ISTN. We need the right evaluation methodology and test case for the ISTN to evaluate a lot of internet-working technologies. We believe that fits the charter of the BMWG work. So that is why we wrote this draft and submit here. But I also agree with Sarah that maybe we need some clarifications for the problem, requirements, and most important, maybe the performance metric. For example, whether we can use the traditional metrics like the latency or throughput, coverage, and the other metrics to quantify the performance or the benchmark of the ISTN. Or maybe we need to seek for some new specific metric for ISTN, maybe like the constellation. Just I have a very simple question. For example, Starlink has already launched about 1,500 satellites in the orbit, and they plan to launch, for example, 43,000 of satellites. But how many satellites really we need to support the global internet? So what is the constellation utilization, and how can we evaluate manning the network performance from the network perspective of ISTN? So such metric or such a test case and benchmark methodology can guide us to construct the future ISTN. So that is why we want to roll this draft and submit this draft to this group. And I'm very happy to if I can get some further recommendations or suggestions from the chair of the and other BMW folks. So you are more than welcome to give any questions, recommendations, and suggestions from the mail list or just direct mail to me. Thank you.
Well, you're very welcome. Thank you. And you know, I think one of the other points that came up is if we can recruit some new members of the audience from these new networking providers, the space LEO network providers. I mean, that would give us a real leg up in trying to make the decisions of what's valuable to this audience and what would they like to know now, and how would this help them choose the equipment they want to add to their networks and modify existing protocols and so forth. So these are the kinds of questions that you know, we could possibly begin to help with in BMWG. But there's a ways to go here. I mean, most of what I hear is research, and I think everyone would generally agree with that at this exact point in time. Although, you know, there are production networks out there, so that's the, you know, that's the other side of it. It's way out of the lab. It's people are using these things right now, and 4,500 satellites is nothing to sneeze at. So very good. All right. So we're a little bit over time, but I'm really glad that in this session we had some chance to give some extra time to this, Zeki, because you know, it just happened to work out that we had some extra time in this session to handle it. So usually we don't. So it's worked out well. All right. Well, we encourage you to keep working on it and try to draw in some audience members, and then we'll you know, from the industry, and then we'll take it from there. Thank you.
Thank you, Pressure, and thank you.
Okay. So at the end of our agenda, any other business? Okay. Well, thanks very much for participating today, everybody. It was a useful session, and we shared a lot of information and test results and progress. And I think that that's what we're always looking for here during our sessions. So again, thank you. We'll see you on the mailing list, and bye for now.
Thanks, folks.